Chemical properties of alkaline earth metals. Compared to alkali metals, alkaline earth metals are less reactive because of their small size and high ionization enthalpy. And reactivity increases down the group. Reactivity increases down because the ionization energy decreases, electropositive character increases. So, reactivity increases down the group. So, first chemical property, reactivity towards air and water. Reactivity towards air and water. So, first elements beryllium and magnesium. They are inert to oxygen and water because they form an oxide film on its surface. Okay, but when they are powdered, they are reactive. Okay, powdered beryllium burns on ignition and give beryllium oxide and beryllium nitride. Okay. Similarly, magnesium, which is more electropositive, burns with dazzling brilliance in air, and a large amount of heat is evolved and gives magnesium oxide and magnesium nitride reaction with air. Okay. Next elements calcium, barium and strontium. Okay. Calcium, strontium and barium. So, down the group reactivity increases. So, they are readily attacked by air and form oxides and nitrides. Okay. For example, in the case of barium, on oxidation gives BaO. At high temperature, the oxidation takes place again and form peroxide BaO2. Barium peroxide is obtained. Next, reaction with water. With water, vigorous reaction even in cold and form hydroxides with water. They form hydroxides. Okay, for example, calcium. Calcium on reaction with water form calcium hydroxide and H2. Okay, so down the group, the reactivity towards oxygen and water increases down the group. Okay. Next, reaction with halogens. Second property, reaction with halogens. So, alkaline earth metals when heated with halogen, alkaline earth metals directly combine. That is, for example, calcium plus Cl2 on heated, it forms CaCl2. But for beryllium halides, example BeF2. BeF2 is prepared by the thermal decomposition of NH4 twice BeF4. Okay, by the thermal decomposition of NH4 twice BeF4. From this compound only we can produce BeF2, and BeCl2 can be obtained from its oxide, and the reaction will be BeO plus carbon plus Cl2 at a temperature of 600 to 800 Kelvin. BeCl2 is obtained plus carbon monoxide. Okay, this is the reaction. So, by this method only BeCl2 can be prepared, and beryllium halides are covalent in nature. Beryllium halides are covalent because of the smaller size of beryllium and its high polarizing power, and it forms chains like this, Be okay. Like this it forms. Okay. X2Be, X2, like that it forms a chain. Okay. Other halides are ionic in nature. Okay. Next, reaction with hydrogen. Reaction with hydrogen. So, all metals except beryllium form MH2, metal hydrides. Okay, beryllium hydride is less stable. Okay, they are less stable, and beryllium hydride can be prepared from beryllium chloride and lithium aluminium hydride. By this method only we can prepare beryllium hydride 2BeH2 plus LiCl plus AlCl2. Okay, like this we can prepare beryllium hydride from beryllium chloride. Okay, and beryllium hydride is polymeric, that is BH2 n times. It is polymeric and it forms hydrogen bridge and form a chain like this, BeHB, form hydrogen bridges. Okay, like this is goes on. Okay, BeH2 n times. Okay, the polymeric form. It is in the polymeric form. Okay, now next, fourth reaction, reaction with acids and bases. So, first reaction with acids. Reaction with acids. All metals reacts with acids except beryllium. Beryllium reacts, but it reacts slowly. Okay. So, magnesium, for example, magnesium with HCl, hydrochloric acid, and form MgCl2 plus H2. Okay. Next, reaction with bases. Reaction with bases. Beryllium is amphoteric in nature, so it also reacts with sodium hydroxide. Beryllium is amphoteric. It is amphoteric and it reacts with NaOH, that is Be plus 2 NaOH. It reacts with sodium hydroxide 2H2O and forms sodium berylate. Okay, Na2 BeO2 2H2O, that is sodium berylate. Sodium berylate is obtained plus H2 gas is evolved. So, beryllium is amphoteric. It reacts both with acid and base. It reacts with acid very slowly, and beryllium reacts with sodium hydroxide and form sodium berylate. Okay. Next, all alkaline metal hydroxides obtained are bases except beryllium hydroxide. Okay, they produce beryllium, metal hydroxides are obtained. Okay, all metals produce metal hydroxides and beryllium hydroxide is amphoteric in nature. Okay, and all other metal hydroxides are bases. Okay, so what about the basic strength in the group? The basic strength of hydroxides increases down the group. Basic strength increases down the group. Also, solubility also increases down the group. So, basic strength and solubility of metal hydroxides increases down the group. Okay. But beryllium hydroxide is amphoteric in nature. Next, reducing nature. Next property, reducing nature. What about reducing nature? All are strong reducing agents. All are strong reducing agents. Okay, but they are not as stronger as alkali metals. Okay, so all alkaline earth metals strong reducing agents, and this reducing property is less than alkali metals. Okay, this is due to their large negative value of reduction potential. Okay, large negative value of reduction potential. So they are strong reducing agents. But if we compare beryllium, beryllium has less negative value of reduction potential. Okay, but it is a strong reducing agent, less negative value of reduction potential, but strong reducing agent. But it is a strong reducing agent because of its smaller size, they are more hydrated. Because of their smaller size and their high polarizing power. Okay, and it has high hydration enthalpy due to their smaller size. High hydration enthalpy. Okay, so due to their high hydration enthalpy, they can easily lose electrons and they are strong reducing agent. Okay, this much about the reducing nature of alkaline earth metals. Okay, next, seventh property, solutions in liquid ammonia. Solutions in liquid ammonia. So they dissolve in liquid ammonia and give deep blue-black solution. Dissolve in liquid ammonia and form deep blue-black solution. Deep blue-black solution. This is due to the formation of ammoniated ions. Ammoniated ions, and the reaction will be like this: M plus X plus Y NH3 gives ammoniated ions, that is M NH3 X times 2 plus, and so these are the ammoniated ions. Okay, so due to the formation of these ammoniated ions, they dissolve in liquid ammonia and form deep blue-black solution. Okay, from these ammoniates we can recover M NH3 6 times 2 plus. We can recover this ion. Okay, so these are the important chemical properties of alkaline earth metals.